Today you're going to be using the quadratic formula to find the zeros of a quadratic equation. The zeros are also called the y-intercept. They're also called the solutions to a quadratic equation. This is one of those formulas that people sometimes memorize. Because you have a note card on the test, you don't have to memorize it for me, but there is a way to memorize it. People sing it to the tune of Pop Goes the Weasel. So this is the quadratic formula. There's a weird symbol in this formula that you may not have seen before. It's a positive sign and a negative sign. The reason for that, that symbol is that usually you will have two different answers, one for when you add and one for when you subtract. This part of the quadratic formula is called the discriminant, and the discriminant tells us a lot about our answers. If the discriminant is positive, then you have two real solutions to your quadratic. If it is positive, you have no complex solutions. The way the graph looks, if you have a positive discriminant, is either your vertex is below the x-axis and the quadratic opens upward, or the vertex is above the x-axis and the quadratic opens downward, and so it would cross the x-axis in two different spots. If the discriminant is 0, then you have one real solution, and that solution is the vertex. So what that means is that either your vertex is on the x-axis and your parabola opens upward, or the vertex is on the x-axis and your parabola opens downward. There will be no complex solutions. Your real solution is considered a double solution because your graph goes down to the x-axis and then bounces back up. The third option is that your discriminant is a negative number. If your discriminant is negative, then you have no real solutions, which means you don't see any x-intercepts on your graph. You would have two complex solutions, which means that your solutions would have I in them. Complex solutions don't show up on a graph because the graph is the real numbers, and complex solutions are not real. When your discriminant is negative, the way your graph looks is that your vertex is above the x-axis and your parabola opens upward, so it never crosses the x-axis, or maybe your vertex is below the x-axis, but then your parabola opens downward, so it doesn't cross the x-axis. So here's our first example. It just asks what types of solutions does the equation have. So the only part of the quadratic formula that we care about for this is we care about the discriminant. The discriminant is b squared minus 4ac. So the first thing we're going to do is find a, b, and c. A is the number in front of x squared. Make sure you don't include any x's with that. A is just the number, the coefficient. B is the coefficient in front of x, and c is the coefficient with no variable part, so it's the constant term. When you are using a, b, and c, make sure that your quadratic is written in order, or at least choose the a that's the number in front of x squared and the b that's the number in front of x. So your discriminant would be, for this problem, it would be b squared. And I recommend, now that we're substituting into this formula, this is like the format of the formula, and then we're going to substitute numbers in. I recommend putting parentheses in, because when you put parentheses in, you're protecting your numbers from losing a sign or whatever as you're working. So when you put in 8 here, you put parentheses around the 8. And when you put in for AC, you're going to put 16 inside of parentheses, and you're going to put 1 inside of the parentheses. If you type exactly this into one of our graphing calculators or scientific calculators with parentheses exactly as I wrote them, then your calculator will tell you the answer. So you don't have to do all of the steps yourself. You can type exactly this with parentheses exactly how I have them, and your calculator will do the work for you. If you're doing the work yourself, you have to remember order of operations. So the first thing you would do is exponents. So this would become a 64. And then the next thing you would do would be, well, normally you would do parentheses first, but there's nothing to do inside of those. And then you would do any multiplication and division that you have. So 4 times 16 is 64, times another 1 is still 64. And then when we subtract, we get 0. Again, it's okay to type into your calculator exactly that line. If you're doing it by hand, you have to be careful about order of operations. Okay, so now what this tells you is the discriminant is 0. That tells me that this equation has one real solution. It has no complex solution. It has one real solution. And that's from this information on this page. We got a discriminant of 0, so we have one real solution. All right, here's one for you to try. Please pause the video and then restart after you have tried the problem. Did this problem, I got that the discriminant was negative 23. Because the discriminant was negative, that means that there are no real solutions and there are two complex solutions. I would expect my answer to have eyes in it. Now we're going to look at a real world example. We've got a tennis player. She tosses the tennis ball straight up into the air and then she hits it with her racket. So we want to know, when will the ball reach a height of 4 meters? Or will the ball reach a height of 4 meters? So the number we have here is a 4. Then that 4 is a height. So that's going to go in for h of t. And we're trying to figure out whether that equation would have a solution. So we're going to write 4 equals negative 5t squared plus 5t plus 2. And we can't do the discriminant unless we have an equation that is equal to 0. So we need to make sure that we move this 4 over to the other side of the equal sign before we start. So then this is equal to 0, and then we can do the quadratic formula. So a big thing to get out of this problem is that you have to start with making sure that your equation is 0. And so then we can find a, b, and c. So a is negative 5, b is 5, and c is negative 2 because we moved the 4 over. I'm going to do the discriminant over here on the left because I don't have room. So the discriminant is going to be a squared minus 4, b squared minus 4ac, sorry. The discriminant is going to be b squared minus 4ac. So I'm going to fill in my numbers. I get 25. So be really careful with negative signs. This 5 is a positive 5, and I square it. I get 25. And then I'm subtracting 4 times negative 5 would be negative 20. So I'm subtracting a negative 20, except then I'm multiplying by a negative 2. So I'm actually subtracting a positive 40. Again, if you type exactly this into your calculator, you don't have to worry about order of operations or signs, because you can type it in exactly like that with parentheses and it will tell you the answer. But if you're doing it by hand, you would get negative 15. So that tells you that you have no real solutions, and that means that her tennis ball will never reach a height of 4 meters. 4 meters is about 12 feet, so that is pretty high for a tennis serve. So the answer to this is no, because the discriminant was negative. We have no real solutions. This last problem is kind of an extension of this idea with the discriminant. We were looking for what values of b will cause the quadratic to have exactly one solution. Well, one solution means to us that the discriminant is equal to 0. So we're going to set our discriminant equal to 0 and figure out what b would have to be. So a for us is 2, b is b, we don't know what that is, c is 18, and so we're going to set it up as the discriminant is equal to b squared minus 4 times 2 times 18. So the discriminant is equal to b squared minus 6 times 18 is 144. That's where you couldn't type it all into your calculator because you have a B, but you could type 4 times, you could write 4 times 2 times 18 on your calculator, so you don't have to do that math in your head. So now we want this to be equal to 0, so we're going to set up an equation. And we're going to add 144 to the other side. And so then we get b squared is equal to 144. So to undo the squared, we're going to take a square root, but there are two possible answers because there's positive or negative the square root of 144. There are two numbers that I can square and get exactly 104. One of them is 12 and the other one is negative 12. This is the first part of this lesson. We were really focusing on just figuring out what the discriminant was. My homework got misnamed. So for tonight's homework, if you do for the first homework assignment, if you do 6-1B in the online homework and 6-1A on the paper homework, then you know how to do that with this lesson.